reminder, tomorrow tutorials 1:15 to 2:30. And then Friday, Calculus Study Jam. It's going to be us. It's going to be a bunch of Calculus AB students from 4 to 6, or as much of that as you can stay for, working on a whole bunch of different things. How many of you guys are planning on staying on Friday?
Me.
One. Like, seriously, like, this is going to be your #1 opportunity to study and just focus on calculus. I think you're going to leave Friday feeling like, I'm done. Maybe you just need to like review flashcards Sunday night, Monday morning, in the middle of the exam, you know, for those of you that are speaking. Great. Myra. I'm not going to be here Thursday after school. Thursday I'll be at Northside. Sorry. It's a thing. Huh? I don't know, but you could ask him.
Why are you whispering?
She has a question for you.
Are you going to be here Thursday? For Crown night?
Yes.
Okay.
I will be focusing on the Greek but I will be here.
Okay. Alright, so enough about that. Alright, so last night's homework, we're just gonna check this real quick, put a check mark if it's right, put an X if it's wrong. Yay! Aaron's got number 1. Number 1 is A. Number 2 is C. What's going on here? And number 3 would be D. 1A, 2C, 3D. How many guys went 3 out of 3? Get all 3 of these right.
Can you, yeah.
Yeah, we can talk about number 3 when we're done. Okay, number 4 is C. Number 5, D. Number 6, C. Number 7 is E. And number 8 would be B. Looking at the back, how many of you guys went 5 out of 5? Okay, like this is a good place for us to be. There was a request for us to talk about question number 3. 3. All right, you guys are gonna kick yourselves. I know you will, because you should. Okay, so a curve has a slope of 2x plus 3. Another way to say slope in calculus class. Derivative. So the derivative is 2x plus 3. If y prime is 2x plus 3, how would I ever find the original function? I would integrate it to get x squared plus 3x plus some constant. And then using the initial condition, you'd plug that in and you'd figure out what the c value is. Was this the issue? Not connecting slope with like, this is derivative?
Yep.
Okay, I do think this question could, I mean this is from 2003, so it's a while ago. I think this question would have been maybe more obvious if it had said a curve has, all tangent lines to the curve have a slope of 2x plus 3, right? So then maybe you'd get like the slope of the tangent line and you'd think derivative. But generally speaking, in a calculus class, when we talk about slope, it's slope of tangent line, and that has to be derivative stuff. Okay? So if you guys could count up how many you got right out of the 8, put that at the top of the paper, and leave it in the middle of the table, that would be appreciated. Alright, let's talk about tonight's homework. Tonight's homework, and the only homework that we're going to get for the rest of this week, comes from that BC practice packet that I gave you that had all the multiple choice questions. I got to work through almost all of those last night while I was at urgent care, getting them to like help me breathe again. Watch. I can breathe. That's good. Yeah, I was like, we can go to the emergency room. I'm like, no, it's semester exams are coming. We don't have time. I'm like, give me the shot and I'll go away. So all the homework is going to come out of that practice packet that I gave you yesterday. It was like 114 pages. Okay, I worked through all the multiple choice questions last night. You need to do tonight questions 1 through 8, 10, 14, and 35 to 37. In total, that's 13 questions. That's going to be about how many you're going to do every night this week. 1 through 8, 10, 14, 35 to 37. What I'm going to ask you to do is you can do the work in the packet, you can do the work on a separate sheet of paper, that's fine. But because you're going to need this packet every single night for homework, I'm not going to pick the packet up from you yesterday that doesn't make any sense. So probably the best thing to do would be to do the work on a separate sheet of paper so that if you are making some mistakes, I can look over it, I can give you some written feedback. If all the work happens in the packet, that's fine too. It just means I can't give you any feedback because I can't take the packet from you. Does that make sense? Okay. Good enough. As you work on tonight's homework, you're going to be like, hey, why is this question asking me about limits? We've been studying the integral. The homework is a cumulative assignment covering all the stuff that we have studied since day one. And so you just got to be ready for it. It's going to be coming at you fast and furious. God rest his soul. Sorry. Okay. All right, so here's the goal for today. The goal is to spend about half the class closing out on Unit 6, which is all integration stuff. I have picked 3 problems that I think are going to push even the best and brightest minds in the room. David, even you are going to be challenged by each of these questions. Thanks, Paloma. I have no doubt that in each question you're going to see stuff that you're like, oh, I kind of know what to do here, and then you're going to hit something else and be like, I have no idea what's going on. So what I want you to do is find somebody that you can work with for the next 2 minutes. You're going to get up and move around a lot. Find somebody you can work with for the next 2 minutes.
Same table, different table?
It can be from the same table for this first round, and then you're going to have to move. Question number 1, you get 2 minutes to read through this problem, come up with your plan. Everyone is going to get stuck at some point, I'm sure, and that's when we'll talk. 2 minutes.
Get that turned off.
Okay. So there is a wide range out there of legal mathematics and some illegal stuff as well. Okay, here's what I'm interested in with this problem. Let's get some hands on this. Things that you know for sure. You don't even need to think about something about this problem. You're like, I know with confidence. Fill in the blank. Celeste.
This is a definite integral.
This is a definite integral question because.
Oh, because it's asking for the bounded area.
Bounded area, and it doesn't seem too bad. They gave you all the bounds, right? So when I'm really excited walking around, everybody and their mama has this set up as their start. Congratulations, mamas. First point. And then we run into a problem. Well, some of you recognize it as a problem. Others of you have blown past this and said, it's no problem. At no point have we actually talked about how do you go about integrating absolute value bars. They are different from parentheses. They are. They do different things.
You just kind of wrote it in absolute value.
Yeah, everyone was like, oh, I'm just going to integrate this stuff and put absolute value bars. Maybe that's a thing. Yeah, maybe that's a thing. The most successful approach that I saw, let's see, some people also said like, Well, here's the graph of y equals x squared minus 4. I know that for sure. So, like, let me throw some absolute value bars around it. Yeah, that's okay. Well, let's have a conversation about the graph. What do the absolute value bars do to the graph, Aaron?
They make it so that no y value is negative.
They change this graph so that there are no negative y values. Another way to say that is, you're going to have some cuss points, good word choice. What's going to happen is that this part that's below the x-axis gets reflected up above the x-axis. I know I'm going a little fast. Is everybody okay with this part?
Yeah.
So what am I asking you to do? I'm asking you to find the area from, here's x equals 0, to x equals 3, that's somewhere out there. I want to find that area. And now you might start to get excited and you're like, oh, it's a circle and a triangle. These are more bad thoughts. These are not circles and it's not a triangle because we have different curving. The key is that we're going to have to split this integral into two completely different integrals. Number one, why do we have to do this? And number two, where do we split it? Where would we split this integral? Lewis?
We split it where x equals 0.
At x equals 0, you want to split it?
Y equals x.
Oh.
Okay, from the graph, there's like two very different regions going on over here.
Yeah.
David, where do you want to split it?
We'll split it at the root.
At the root. Do we know where the root is?
It will be at x equals 2.
Right, I tried to pick a friendly function so you can see the root. And the root has to be 2. So here's the thing. If you choose to split it, we're almost at the point where you guys are going to finish it off from here. I'm going to choose to rewrite my definite integral this way. I'm going to do the definite integral of the absolute value of x squared minus 4 from 0 to 2, the definite integral of the absolute value of x squared minus 4 from 2 to 3, and I want to ask you to think about what do the absolute value bars do. Aaron, what you said is the absolute value bars make it so that there are no negative y values. So what happened to the graph on this interval 2 to 3? Did anything happen to the graph? If you think about the graph of x squared minus 4 compared to the graph of the absolute value of x squared minus 4, what happened? Nothing happened. So in that case, from 2 to 3, I don't need absolute value bars. I can get rid of them.
So would it matter
Well, what matter?
if you delete them or not?
I mean, that's kind of what I mean. Control X. Control X. We don't have a way to integrate an absolute value. We have no rules for that. Good question. But what about over here from 0 to 2? Did we need the absolute values?
Yes.
We absolutely needed them. And what did they do to the graph? They took all these negative values and turned them positive. There's another way you could do that. What about if instead of absolute value bars, what David just said is throw in a negative? That has the exact same effect as the absolute value, right? The absolute value bars just took negative y values, make them positive. On this interval from 0 to 2, by multiplying by a negative, all these negative values just became positive values. And this should be a very comfortable problem to finish off?
Yeah.
Okay, finish it off without looking. I'm going to finish it off.
You say read?
Breathe.
Oh.
I mean, reading is nice too.
Is that what you were
Learn how to read recently?
Finish the problem. Or I won't be the only one around here struggling to breathe. confident in how long I've been here for.
Stop.
Don't cheat, don't love. Doing the key at the end of those. Good. Love it, right? And so now it's as much as I'm hot. Good. Friends back here, we doing okay? Just a whole bunch of. Love it. Love it. Good. Okay, good. Let's finish that off. Good. So if all goes well, should be 23/3. What I really care about, can you find the antiderivatives correctly? Do you know to evaluate by plugging in the top number first, bottom number second, and then anything after this, it's like middle school mathematics. Not to be insulting, but all like the calculus, all the big thinking, you stopped big thinking here. Now it's like little thinking. Everybody okay? All right, time to switch. You want to pick a smart partner for this one.
Louise, I mean,
Go.
Louise!
Some of you may regret your decisions in a little bit.
Devo!
No, it's great. I already got him.
Mr. D!
Come on,
Why don't you join?
Come here, David.
You told me to choose a great partner.
Come here, David.
I would be a great partner.
Vale, move.
What?
Please. Your partner's moving.
Oh my god, it's cold.
All right, friends, let's get rocking on this one. I'm really interested to see what your smarticle particles do with this one. Carmen's like, me too.
The velocity of the flow of blood distance r from the central axis from the artery.
Wait, distance R by the radius R. Wait,
There's different R's.
well, I see that. But
You would have them the same.
which R is it? Oh, so the little R is the distance. The big R is the integration that we're using. And the radius.
Okay.
From 0 to the radius.
0 to r. So integrate v. I don't really know what.
Okay. All right, before we have too much conversation about this, I just want to stop everybody. No one's actually drawn a picture of this.
No.
So everyone's got some sort of an integral showing up on their paper, and maybe you're integrating the right way, maybe you're not. I want to talk about the picture. Okay, so the velocity v of the flow of blood at a distance r from the central axis of an artery is given by that. Yeah, okay, now I understand why no one's actually drawn a picture. When we talk about artery, what do we mean?
Thing. Yeah.
An artery
Oh,
is
look,
an
we have a guest.
Hello, guest. What's this? Is this loss of credit or promotion? No, I'm old enough.
Oh, it's my attendance thing. I know I
Yes,
got
it's your attendance
fixed.
thing. There you go.
I need to
All
get
right,
that fixed.
artery. Back to the conversation. Arteries.
Too bad you're.
What are arteries?
arteries.
This is true.
Myra, what's an artery? Blood, veins, stuff, arteries. Okay, something having to do with heart. Thank God this is not an anatomy and physiology class. We would be doomed. When I think about an artery, I just think of like a tube.
Yes.
Okay? So here's your tube. Now the job of this artery is to like move blood around, but here's the tube. And as we've got blood going through, and of course my blood here is blue, sorry. Okay, blood is flowing through this artery at different distances from the center. What do we know about this artery? It has a radius of big R. So if this blue line that I drew here is the center, then what I know is the distance from the center to the edge is big R. But we're going to have particles that are right on the center. We're going to have particles that are just below. We're going to have some that are just above. We're going to have some that are just like up against the artery wall. Okay? Mm-hmm. So each of these little particles has like a distance little r, and these are different little r's. The little r's are going to change, that are telling you how fast it's flowing through if you're at that distance away from the central artery. Like big picture, this is what we're talking about. Everybody okay? Okay. So K is some constant of proportionality. Find the average rate of flow of the blood. How on earth would I find average rate of flow of the blood through the artery? How would I find average anything?
Oh, it's the same, like the last question from the homework.
And Andrew, what was your thought then? How do we find the key word here that I was hoping everybody was going to grab onto? Average. How do we find average, Lewis?
The integral over the thing.
So there was this average value formula that said the average of f of x on the interval a, b. We find the integral of f of x with respect to x from a to b. And then
over b minus a.
divide by the length of the interval. So if what I want is the average rate of flow of the blood, I have to know what is the rate of flow of the blood. That's what this v is. So k times big R squared minus little r squared. I've got to integrate that from where to where?
0 to R.
From 0, big R or little r?
Big R.
Big R. Big R is the constant. We're saying that we have these little blood pieces, particles, sorry I don't have the right word there, that could be on the central axis, they could be like at the artery wall, so we should be going from 0 to R. And then we're going to divide by
Big R.
big R, and we're going to integrate with respect to
Little r.
Little R.
right? What's the thing that's changing? What changes is little r. You're going to have some that are this far away, you're going to have some that are that far away, so we're going to integrate with respect to little r. For those of you that feel comfortable finishing off the calculations, go for it, but I'm just going to talk it through for anybody who wants to go with me. Alright, so if I'm going to do some math here, who are the folks that are doing this with me? Looks like Polymon, maybe David, okay, Giselle. Legal things that you could do here that might make life better. Maybe you want to distribute the k, that would be legal. K times big R squared, k times little r squared. Another thing,
You take it out.
right, one of the properties of integrals is I can factor out the k. Okay, so now I've got k times the integral of big R squared minus little r squared dr from 0 to big R divided by big R. What I'm thinking I'd like to do, maybe it'll make writing a little bit easier, rather than dividing this whole integral by big R, would it just be okay to call this like little k divided by big R? Just like bring that big R out in front. So now I've got little k over big R, integral from 0 to big R.
You said k over k.
Oh, I did k over k, awkward. Now I'm going to integrate with respect to R. No. It's not going to be big R to the third over 3. R, in this problem, big R, is a constant. It's the radius of the artery, which isn't going to change. Your variable is Hey! Your variable is little r. So if I'm going to integrate big R squared, and R is a constant with respect to little r, then the integral has to be, and I want to be really careful with this, big R squared times little r. Little r is the variable, big R is the constant. I'm integrating with respect to little r, leaving big R alone. Minus the antiderivative of r squared over here, little r squared, with respect to r. That's where we're going to get 1/3 r cubed. And then we evaluate from 0 to big R. So we're going to, let's see what we're going to do. We're going to evaluate the antiderivative at big R. Everywhere there was a little r, plug in big R. Everywhere there was a 0, everywhere there was an r, plug in 0. So we've got little k over big R. Looks like big R squared times big R minus 1/3 big R cubed minus little k over big R squared times 0 minus 1/3 of 0 cubed. And if you decide to clean this up, just be careful. Just be careful. Anybody see any cleaning up we can do? Hold on, David. Legal simplifying that we can do. That would make life better. Lewis, what do you say?
You take out the whole right function to 0.
Right, all of this, r squared times 0 is 0, 1/3 times 0 cubed is going to be 0. All this over there is 0. Definitely I would get rid of that stuff. A little bit more that you could do that would really make your life better.
R cubed minus 1/3.
Yeah, big R squared times big R is really r cubed. You've got r cubed, or maybe it's easier to think about it as 1r cubed minus 1/3 r cubed. So we've got k over big R. Big R cubed minus 1/3 of big R cubed is going to be 2/3 of big R cubed. Almost done. I've got an r in the denominator. I can cancel out with one of these to get 2/3 k r squared. Okay. Don't freak out about the artery problem. My goal was to give you guys a push. For the folks that went solo with the integration, how did it go? Okay. One last change of partners. You guys are going to do challenge problem number 2, please. There may come a time that you thank me for this. Challenge problem number 2. It's on bottom of page 20. This is going to be our last integration problem, and then we switch into review mode.
Torque cycle. Oh.
Oh, the respiratory cycle, because it's never mind. Because can't. There's like.
Ha ha ha.
Yes.
No, 3.
I said 6. 6 at the bottom of 21. Dude, that's pretty slow. Liters of air. Liters of air.
That's actually how you measure air.
No, you do just breathe. You don't measure air?
Okay. What do I know? Today.
For 2 minutes. Okay.
We need this. So we'll have you guys do
And because
Or you
you're
can get out.
take it out.
Can you take that?
Yeah, this is.
I'm trying to talk about something else.
In this treat this as IT being one spec and one half, the opposite of what it was, all of it times 2, so 2 sine IT. 2.
Could actually be,
You know,
So then it'd be 1.75.
So what is the idea of that was obviously.
Right, but then it'd be
I'm absolutely total volume there.
Or you just jump straight to
So
the.
V of T is how fast you're
Limit times.
because when it's a rate function,
Yeah,
it's
pi
saying
over
how
two,
fast
when
something
pi over
happens, the
pi
integral
over
tells
two.
you how much.
so it'd be -2. Negative power.
Yeah.
No, that's not what you
oh yeah, it is.
And then you do. That's it.
V in this case is, it's not really velocity.
That's 45 degrees, right?
It's
Cosine of
how
power.
fast.
So,
So V is how fast your
Yeah.
change
No, it's not.
and this question
It's
is
zero.
asking you for.
I was like,
Cosine of power equals 9.
oh, it's 90. I thought it was 45. I was thinking of
But now you gotta
90.
make sure.
Power 4.
So V of T is a rate function, which means it's asking the question like how fast something happens. Most of you guys have figured out if I want to get to total volume, I need to do an integral from 0 to 2 V of T dt. This guy's a rate function. It says how fast something happens. If I find the definite integral, it's going to tell me how much. So to do the integral from 0 to 2 of 1.75 pi t over 2, one thing I'd probably do is get that 1.75 out. So 1.75 integral from 0 to 2 sine pi t over 2 dt. I didn't see anybody do it, but I want to just have a conversation about this. Is this part legal? Sine pi over 2t, pi over 2 times t dt. Legal. And better because now I can see that this is k. And the antiderivative of sine kx or sine kt is, how does that work? Antiderivative of sine kt would be negative,
-2 pi.
well, it would be negative 1 over k times cosine kt. So it's going to be negative 1 over pi over 2 cosine, whoa, pi over 2t, pi over 2 times t. Don't forget this 1.75 that's out front. Right, there was a 1.75 there. That looks a little ugly. It's 1.75 times all this, so that's negative 2 over pi. I think that's negative 3.5 over pi.
Yeah.
Times cosine pi over 2t, evaluate from 0 to 2, plug in the 2, evaluate, plug in the 0, evaluate. I think we're going to get negative 3.5 over pi, cosine, pi over 2 times 2 is cosine pi, minus negative 3.5, is that cosine 0? Cosine pi? Should be negative 1. So this is now positive 3.5 over pi. Cosine of 0 is 1 times 3.5 minus a negative, so we've got another plus 3.5. Did I drop a pi somewhere? Sorry. That should be negative 3.5 over pi. So this is 3.5 over pi, and when I add those together, it's going to be 7 over pi. Sorry, that was a little sloppy. Big picture, is everybody okay? Okay. So here's what I want to do. You guys have like 17 minutes left in this class period. I think the #1 best thing that you can do would be to get started on the homework assignment. It's a mix of all the things. If you want to come back to your home groups and take out those vocabulary slides that I gave you, I'm going to stop filming at this point and I'll just post the video. But we're just going to work on multiple choice questions for the rest of the period.